Alright, we're being asked to solve this exponential equation. By the way, this is an exponential equation because the variable we're trying to solve for is up here in the exponent. What we're going to need to do is use logarithms to solve this because they have a property that allows us to bring this exponent down to like the base playing field. Here's the first step. The first step is that you want to divide everything by 1,000 because you're trying to isolate the exponential expression here. So we're dividing by 1,000. And that just gets rid of the 1,000 on the left hand side. And a quick way, by the way, when you're dividing a number with a bunch of zeros by 1,000, this 1,000 will cancel with 3 of those zeros, leaving us with just 500 there on the right hand side. On the left hand side, we've gotten rid of that 1,000, so what we have now is 1.04 to the 2t. Now you can keep parentheses around the 1.04, but we don't need it anymore, so I'm not going to add it. Alright, so the next thing we're going to do, we're going to apply log to both sides. We're going to use log base 10 just so we can get our calculator in the action. So I'm going to apply the log of this left hand side, and I'm going to apply a log to the whole right hand side here. So what we have here is a log of 1.04 to the 2t, and then on the right hand side here we'll have the log of 500. The next step is really important. It's the reason that we brought these crazy logs into the conversation in the first place. We have a property of logarithms that says if you're taking the log of something that has an exponent, that exponent can be moved to out front of the log as a multiplication. So we're going to do that in the next step. And again, this move right here is the sole reason for applying logs to both sides of this equation. What we get is now 2t times the log of 1.04 equals the log of 500. It's really important at this point to understand the log of 1.04 and the log of 500 are just decimal numbers that we could plug into our calculator and figure out. I personally don't want to deal with ugly decimals at this point. I'm going to deal with it in a second. So the next move that I'm actually going to do is I'm going to, because I'm trying to isolate the t here, my variable, I'm going to divide both sides by this number, whatever this number is, the log of 1.04 to both sides of my equation. And as always, dividing this is just going to cancel this log of 1.04 on the left hand side. So what I now have is 2t equals the log of 500 divided by the log of 1.04. Now I'm going to get my calculator involved. I have this 2t, and now I'm going to divide these logarithms on my calculator, and when I do that I get the log of 500 divided by the log of 1.04 is 158.452195. I don't need to use all of those decimals, but since I'm asked for a certain amount of accuracy, I'm going to keep as many as my calculator has given me. The last step, I simply just need to divide by 2 because I'm trying to find my t value. So dividing by 2 to get t by itself, dividing this big ugly number by 2. One pro level move, by the way, is I'm not going to retype this ugly number into my calculator. I have it currently showing, and I'm just going to type divided by 2, and my calculator will know that I'm trying to divide that number by 2. So I'm letting my calculator remember that crazy number for me. And my calculator gives me that number divided by 2 is 79.2261. So there you go. A quick review on this real fast of what we did and where the craziness happened. We had this original problem where we have our variable up in the exponent. What we're going to do is isolate the exponential factor, and that was this factor here, the 1.04 to the 2t, because that is the one that has an exponent with the variable. I do that by dividing both sides by this 1,000 to get rid of it over here on the left hand side, and obviously that affects the right hand side in this way. Now that in the second step I've isolated the exponential part, I apply the logarithms here to both sides of the equation. That allows me to use this property that gets that variable down to this base level out of the exponent. And the last moves are really just linear algebra moves where I'm dividing stuff away, isolating my t, calculating these logs, and getting my final answer.